So we have our blinking LEDs and we want to save the scale value that we use between when we turn the power off and then when we turn it back on again. So something that is good to remember is that the Arduino has three different types of memory. The first is the flash memory, and this is where your program is stored, and that's always preserved when the power is turned off, but we can't easily modify it while we're running our sketch. The second kind of memory is RAM, and so this is where the temporary variables are stored when the program is running. And then there's also a third sort of memory called EEPROM, and this is a special sort of memory where we can store a value when we're running our sketch, and that's preserved when we turn the power off, so that when the power is turned back on and we read that value back, we will get the same value that it was before the power was turned off. So we're going to use this functionality to store the scale value that we use to alter the speed of the blinking LEDs. So let's take a look at the Arduino reference now. So looking at the language reference, we can see that there's a lot of information about the standard language features, but there is some additional functionality that are provided by libraries. And these are extra pieces of code that help us add new functionality to our sketch. So we can go to the libraries reference by clicking here. So there are some libraries which are included with the Arduino development environment, and that's what we're going to use for this. But third-party people, so other people in the Arduino community, can also create their own libraries. So they might have a useful piece of functionality that they want to share with other people. So let's have a look in the standard libraries. We see that the first one listed here is the EEPROM library, and that it's for reading and writing to permanent storage. So let's go ahead and click that. And we see that we have two functions here. We have a read function and a write function. So let's take a look at the write function. We can see here that the syntax that we need to use is EEPROM.write and then the address that we want to refer to and then the value. Now, the EEPROM has, depending on the type of Arduino board you have, around about 1 kilobyte of storage available. And that's labeled with an address from 0 up to 1024. So we need to specify where we want to store it. So let's say we want to store our scale value at position 0. And then we have to specify the value that we want to store. So let's go ahead and look back at our code here. So the first thing you need to do is, if you're using a library, we need to include the library so that the Arduino environment knows that we're wanting to use the extra functionality. So to do that, you go to the Sketch menu and go to the Import Library section and then choose the library you want to import. So in this case, the EEPROM library. And then that will add what's called an include line, which says, hey, I want to use the EEPROM library. So now that we've done that, we can use the extra functionality provided by that library. So let's go down to the point where we choose to set the scale. So at this point, we know that we've got a new scale and that it's a scale that we want to be using, which means we also want to store it. So this is where we'll put our write command. So we go EEPROM, write, and then we need to choose an address. So we'll just use the first position in the EEPROM memory. And then we need to give it the value that it's storing. So in this case, it'll be the scale value. Now, let's save this as a different name. So now we know that hopefully we'll be storing the scale value correctly. Now we can check to see that we've at least got the syntax correct by clicking verify. And that will just compile the sketch without uploading it. So that can be a good way, if you're not 100% sure if your code is correct syntactically, that you can compile it and check that you've got all the I's dotted and T's crossed. So we know that that part is at least correct. So the next step that we need to do is we need to be able to read it from memory. Now, we can actually upload this to the board now. So let's go upload. We'll see it uploading, and then our functionality is exactly the same. We have our blinking LEDs. And if we use our serial monitor to, say, slow it down, and send it, we can slow it down. But then we can also verify that if we disconnect it and then reconnect it, that it goes back to the faster blinking speed. And in fact, pressing the reset button would have the same effect. So we can be reasonably certain that we're writing to EEPROM correctly, but we need to have something in our sketch to read from EEPROM as well, so that we can get the stored value back again. So we want to do that at startup, and so we want to be using the EEPROM read method. So let's take a look at the syntax for that, so that we know how to use it correctly. So we want to read a byte, and then it helpfully tells us, in this case, that the default value, so the value if nothing has been written to EEPROM, is 255. So the values that you can store in EEPROM are limited to 0 to 255. Now, there are other methods that you can use to write larger values to EEPROM, but we're just going to stick with the library that's incorporated with the IDE. So we don't really want to have a delay scale value of 255 because that would make the blinking really, really slow. So we have to handle two situations, one of which is the situation where we've already stored a value in the 0 position in EEPROM, and the other situation is when we haven't stored it, and so in that case we want to use our default value. So let's look at how we implement that in the code. So the first thing we need to do is we need to have a variable which we're temporarily storing our saved scale value in. So let's call it saved scale. And then we want to read the value from the EEPROM memory. And we want to read position 0 because this is where we've written it to here. So at this stage we have a temporary variable which is storing our saved scale. Now, because we don't want to use the value 255 if we haven't already stored the value there, so this would happen if you had a new Arduino and you uploaded the sketch, then we need to check that it's a sensible value. So in this case, we'll say if the value is less than 20, then we want to use it. Otherwise, we don't want to use it. So that's a nice protection against maybe someone else has used the EEPROM for another purpose and has a really large value in there, and we don't want to use that. So if the scale, the saved scale, let's have that correct. And so if we have the saved scale, as long as it's less than 20, then we want to use it as our scale. So let's go and assign that value. Whoops. So this means that if the value that we got from EEPROM is less than 20, then we're now going to use that as our new scale value. So let's go ahead and save that, and then we can upload it. Now when we upload it, the EEPROM value in position 0 will already have the scale that we set in when we first tested the sketch. So let's see what it does. We'll hit upload, it will compile, and then upload, and then we should see our slow blinking, which is what's happening. So what's happening is that we had set a blink speed of 5 and saved that in EEPROM, and so that means that that's the value that was retrieved. And so we can show that that still happens by unplugging it and then plugging it back in, and we see that we still have the slow blink speed instead of the fast blink speed. So let's go ahead and see if we can set it back to our normal of speed of 1, and we see that now it's blinking back at its fast rate. So we can disconnect the power and then connect our battery pack. So again, putting the red into V in and the ground into the black line into the ground, and then we can turn it on and we see that we've got our fast blink. But let's say I'm about to head out to my local waltzing club and say we want to have our disco lights to be slightly slower, so we'll set this to our new scale of 5, and that slowed it right down. And now we can disconnect it, turn off the power to save our battery, and know that when we come back and turn the power on, that our blinking will be happening at the right rate. So, I will see you down at the Wolfson Club.